So we're moving on to a new idea. We're looking at inverse relations and functions. And all we're trying to do is we're just trying to see if an inverse of a function exists. And if it exists, we're going to find it algebraically or we're going to find it graphically. So this first section, this first video that I'm going to show you, shows you how to do it algebraically. And the first thing I want to do is just show you what it looks like, and then we'll do a couple maybe in the next video, or maybe I'll do one like this, and we'll move on. So what I want to do is show you the steps, okay? We always need steps to get from one end to the other. This says, follow these steps to find an inverse function algebraically. It says, use the horizontal line test to confirm the inverse function exists. And all that means is take a look at the graph of that function, whether you do it on your calculator or you remember what that type of graph looks like, and see if you can draw a horizontal line through it. And if you can draw a horizontal line through it and it only touches the function in one place, very much like that vertical line test from the very beginning of the year, by the way, then you know that it does have an inverse and we can do it algebraically. Now we know we can do it. Now, replace the term f of x with y. Hey, we already know that those are interchangeable, right? And then once you put that y in there, you're going to interchange your x's and your y's. That's your inverse. And then you're going to solve for y. Okay? And it seems convoluted right now. It seems crazy right now. But don't worry. You'll see how this works out when I show you this example down below. And then once you solve for y, you're going to replace that y with f inverse of x. It's going to show the inverse of that function. And then you're going to look at that function, that inverse function. You're going to say, hey, are there any restrictions in the domain? Are there any things that don't exist in the domain? And then we'll write out what the rest of the domain is with maybe a hole in the middle. And you'll see it. When we have asymptotes, you'll see that we have holes in the middle, or we have fractions, we have holes in the middle. It'll be very simple to understand. I am going to move up, right? Determine whether this function, 1/4 x plus 3, has an inverse function. If it does, find the inverse of that function and state any restrictions in its domain. Now we know, here is the graph of 1/4 x plus 3. It cuts through 3 and it has a slope of 1/4. It's a linear equation. All linear equations have an inverse, right? Because we could draw a horizontal line, well, even though this graph shows it with pixels and all, horizontal lines, but we could draw a horizontal line through this and it would only hit this function in one spot. So we know that it does exist, so we say, hey, let's go ahead and do this work. We had f of x here, now we're going to replace f of x with y. That was that second step. All right, and then what are we going to do? We're going to switch our x's and our y's. All right, we're going to invert our x's and our y's. So instead of y equals 1/4 x plus 3, we're going to say it's x equals 1/4 y plus 3. And then we'll move into step 3. Step 3 says, solve for y. Well, what do we do to get rid of the 1/4? We multiply both sides by 4. 4x equals y plus 12. We'll subtract 12 from both sides. And y equals 4x minus 12. And then, since we have a y here, we just replace it with f inverse of x is 4x minus 12. Are there any restrictions in the domain? Are there any things, can we put anything in there that doesn't exist? No. So there are no restrictions in the domain. So we could say the domain would be a negative infinity to positive infinity and put parentheses around it, and we would be set. I want to show you a couple of these examples down here, and I want you to think about how you figure out whether these have an inverse. Do we have to do the math, sir? I don't know. But let's just take a look at all four and think about what these graphs would look like. And here, let's take a look at this graph here, right? This graph here says it's f of x is 2x minus 4. So this is so super simple. This is a linear equation, just like the one above, only this one crosses through negative 4. We'll call this negative 4, and it's got a relatively steep slope, right? It's got a steeper slope than 1. And so does this have an inverse? Of course it does, because every linear function passes the horizontal line test. So let's move on to 2. We have, oh, look at that. We have a f of x equals x squared function, but it's just been shifted, right? It's been shifted to the right one space and shifted up 2 spaces, right? That's what we did about two lessons ago. So you should be able to look at this and go, hey, all we do with this sucker is shift it over 1 space to the right and shift it up 2 spaces to the right, but it's still a parabola. We still have a parabola. If we have a parabola, does it pass the horizontal line test? No way. So this doesn't have an inverse, okay? So we're not even going to bother with this one. We're going to say, no way, man. No way, man. All right? So this one is a yes. Let's go ahead and take a look at this. Now this one's a little bit different for you guys. You're not used to seeing these 1 over x functions, these inverse functions on a regular basis. But I know what this looks like just because I've seen it a couple of times. This, we remember, has an asymptote at 0 because with a 5 here, horizontal asymptote at 0. Because with a 5 up there, there's no way that it can possibly, when it's going in this direction, touch 0. It'll never be 0, right? It'll never have a range that touches 0. So when we talk about graphing this minus 2 thing here means it's been shifted over to the right 2 spaces. And then there's an asymptote here, and the x-axis is an asymptote. And then we can graph from here, and it looks something like this. And I want you to realize that even though this looks like it's a horizontal line, it's inching closer and closer and closer to 0, and closer and closer and closer to 0, and closer and closer and closer to 2, and closer and closer and closer to 2. So yes, this one would pass the horizontal line test. This doesn't have any horizontal lines. And of course, f of x equals x cubed. This is a cubic function. We know what a cubic function looks like. Here it is on your graph. Unfortunately, this one crosses at positive 4, but it's still that quick little twist, and there we go. And does this pass the horizontal line test? Yeah, this also passes the horizontal line test. Now, do I want to go through each and every one of these to show the steps? I think you can handle a couple of these. So I'm going to do, well, we'll see if we do all 3. It's not that difficult. So we now say y equals 2x minus 4. Okay, here we go. Let's make it x equals 2y minus 4. Okay, let's add 4 to both sides. X plus 4. equals 2y, and let's divide by 2. X plus 4 divided by 2 equals y. There it is. Are there any restrictions in our domain? No, there's nothing that doesn't exist here, and it's basically the same thing, right? Not a big deal. Super simple. I don't know. Anything really horrible that stands out there? We say domain, no restrictions. Right? And then we'll take a look over here. We'll do the same darn thing. I'll do that one momentarily. We say y equals 5 over x minus 2, and then we switch the x and the y, and we say x equals 5 over y minus 2. And there are a couple of ways we can do it, but suffice it to say, these two things are interchangeable. And I'll show you how it works. You multiply both sides by y minus 2, and then you divide by x, and so they're interchangeable. So we have y minus 2 equals 5 over x. Uh-oh, now we're running into trouble. We're going to add 2 to it, to both sides, to get rid of that. Now we have the new function. Oh, I apologize. I forgot to write this as the inverse function. F minus 1 of x equals x plus 4 over 2. Okay, that's our inverse function. So here we are, and I can rewrite it as f inverse of x equals 5 over x plus 2. And are there any restrictions? Yeah. There's an asymptote, a vertical asymptote at 2, right? So we can never, ever, ever touch, at 0. Oh my God. Doesn't exist, right? So if I put a 0 in here, so we would have a domain that is negative infinity to 0, doesn't include it, union 0 to infinity. And that's how we would do that one. And there's our inverse. All right, last but not least, we'll do the very last one. I can't believe I went through this whole page. I won't post this for you to do. I'll post it for you to take a look at. But other than that, I think you should be good with the whole front side. I'm going to show you how to do this by graphing, by pulling points off of the graph and inverting them in the next video. But let's do this last one. Let's go ahead and replace y equals x cubed plus 4, x equals y cubed plus 4, and then we say x minus 4 equals y cubed, and then we just say the cube root of x minus 4 is y, or the inverse function of x is equal to the cube root of x minus 4. Okay, the domain, is there anything in the domain that I can't use? Actually, no, I can take the cube root of absolutely anything. So we should be good. Other than that, I think you should be able to handle the first part of this, and the next video will show how we do this graphically, looking at a graph, transposing points, and then redrawing what the function should look like.